Hello students, here I am going to discuss about the one more conversion, that is nothing but Fischer projection to Newman projection or Sawhorse projection. In last video I discussed how to convert 3D structure to 2D structure, that means Vegeta structure to Fischer structure. Okay, so in this case this is a 2D representation, that is a Fischer projection representation, conversion into Newman projection or Sawhorse projection. Okay, this conversion I have taken from the one of the standard book for the stereochemistry of the organic compounds, that is written by the Eliel. Okay, it is one of the standard book for the stereochemistry. So here in this case, so actually here in this one is the first carbon, here it is a bottom carbon. So in this case, here just it is a Newman projection. Okay, it is a Newman projection. In this Newman projection, the CHO must be written in a downward direction. Okay, the CHO must be written downward direction. So in this case here, the CH2OH must be written in a downward direction. Okay, so in this case, whatever the groups which are on the vertical line in a Fischer projection must be written like this. Okay, here CHO, that means in this case the CHO it is a first chiral carbon, it is a second chiral carbon. It is a bottom chiral carbon. In this case, it is a bottom chiral carbon. Okay. So here in this case, what are the groups on the vertical line must be written in a downward direction. So here CHO, here CH2OH. And as usually we can write the hydrogen on the left side, here OH on the right side. Here hydrogen on the left side, here OH on the right side. It is the exact Sawhorse projection formula. Okay, actually it is the eclipse reconfirmation. Okay, it is a eclipsed conformation. Okay, so in this case, for suppose rotate this one. So here actually about the 180 degrees I am taking the rotation 180 degrees. So here in this case that becomes like this here. The CHO, in this case hydrogen, this is the OH. So here CH2OH. Okay, here in this case by rotating 180 degrees, here this CH2OH exactly, that means here it is directed in an upward direction. So here OH, that is a downward direction, but which comes to the left side. This hydrogen comes to the right side. Okay, by rotating just 180 degrees. So here we can get like this. Now here in this case, this is a staggered conformation. Okay, this is a staggered conformation or anti-conformation, because here OH, hydrogen, hydrogen, these groups are exactly anti in angle actually. So here in this case here, for this one we can write the Newman projection formula. Okay, Newman projection formula. In Newman projection formula, this is the bottom carbon. That means here bottom chiral carbon here must be written. That means that is a rare carbon actually. Okay, that is a rare carbon. Whatever the bottom carbon in a Fischer projection or Sawhorse projection, that is a rare carbon in a Newman projection. That is the main important point. Okay, a circle is a rare carbon. Circle is the rare carbon. This point is the front carbon. Here, this is the front carbon. Here, this is the front carbon. This is the front carbon. It's nothing but bottom carbon in a Fischer projection. Here, bottom carbon in a eclipsed Sawhorse representation. It is also bottom carbon. The bottom carbon in these conformations is the rare carbon. Sorry, is the front carbon in a Newman projection formula. So in this case, OH and hydrogen. CH2OH, OH on the left side, hydrogen on the right side. Now here coming to this one here, CHO downward direction and OH on the right side and this hydrogen on the left side. This is a staggered conformation. It is also staggered conformation, but here it is a Sawhorse projection, but it is a Newman projection formula. Okay. Now here from this one, from this Sawhorse formula to Newman formula we can write. So here see this one. Yeah, actually it is a front carbon. So H here OH. This is a CH2OH. And next here coming to this one here CHO and this is OH and this is hydrogen. It is a eclipse reconfirmation. It is a eclipse reconfirmation. but it is a Newmann projection. It is a Sawhorse projection. Okay, very simple. The main point is whatever the groups on the vertical line must be written in a downward direction. Okay, that's it. So as only we can write the molecule. Okay, so here in this case, for suppose um, if given like this, okay, just wait. Yeah. So here in this case, this is a Sawhorse projection formula. How to convert into Fischer projection formula? So in this case, this group here is the downward and this methyl is upward. So but here in this case, in this conversion, those two methyl groups must be in downward direction. So here in this case, rotate this one about the bond 180 degrees. So here by rotating 180 degrees, here the CH3 downward, here hydrogen, chlorine. Now in this case, the CH3 comes to the downward direction and here chlorine exactly opposite and this bromine exactly opposite because that is rotated 180 degrees. Now here we can write this one as only the CH3, this CH3. It is the top carbon, the chlorine on the left side, here bromine on the right side. Bottom carbon, here hydrogen on the left side, here chlorine on the right side. That is a 2D kind of Fischer projection for the this Sawhorse projection formula. Okay. For suppose it is a Newmann projection. So how to convert into 2D structure? That is a Fischer projection. Now here, this one first of all, write in a Sawhorse projection formula. The CH3, this one hydrogen on the left side, this chlorine on the right side. Now here in this case, CH3 downward direction. Okay, the rare carbon is nothing but bottom carbon in this representation. Okay, the rare carbon here in this case bottom carbon. So here bromine right side, here in this case chlorine left side. Now here, while we convert this Newmann or Sawhorse projection formula into 2D structure, these groups must be in a downward direction. That means there must be Eclipse Reconfirmation. So here in this case, rotating 180 degrees. So here the Cl and this is Br as CH3. Now here this CH3 comes to the downward direction and here this chlorine goes to the left side. So here chlorine. Next here hydrogen comes to the right side. Okay. Now here in this case, whatever the groups in a downward direction must be written on the vertical line. So in this case, it is a top carbon, it is a top carbon. Here bromine on the right side, here chlorine on the left side, here hydrogen on the right side, this chlorine on the left side. So that is a 2D structure for this one. Now here we can say the relation between these two. For suppose these two structures are given, then what is the relation between these two structures? Now here we can see here chlorine, bromine, methyl, here methyl, chlorine, bromine, here chlorine on the left side, here chlorine on the right side. So here these two are not the mirror images. So here the relation is the diastereomers. So here between these two structures, the isomeric relationship is a diastereomers because these two are the non-mirror images. Okay, so that is a conversion of Newmann projection to 2D structure. Okay, so I think this trick is very useful for the conversions. Okay, so if you like this video, like my, that means here you can press the like symbol. Okay, thank you for watching.